NEC section 230.94 covers the location of overcurrent protection relative to service equipment. It generally mandates that overcurrent protection devices be placed at the service entrance. However, exception No. 2 to this section permits certain circuits to bypass this requirement. This exception specifically allows for the connection of high-impedance shunt circuits directly ahead of the main service disconnect. The question then becomes, is a transient voltage surge suppressor, often referred to as a TVSS, considered a high-impedance shunt circuit? The answer is yes. To understand why, let's delve into the function of a TVSS and its electrical characteristics. A TVSS is designed to protect electrical equipment from transient voltage surges, which are sudden spikes in voltage that can damage sensitive electronics. These surges can be caused by various factors, including lightning strikes, utility switching, and the operation of heavy equipment. The TVSS works by diverting the excess voltage away from the protected equipment and safely dissipating it. Under normal operating conditions, a TVSS presents a high impedance to the electrical circuit. This means that it allows very little current to flow through it. It essentially sits dormant, monitoring the voltage level. When a voltage surge occurs, the impedance of the TVSS rapidly decreases, providing a low impedance path for the surge current to flow to ground. This diversion of the surge current protects the downstream equipment from overvoltage damage. The key characteristic of a TVSS, which makes it qualify as a high-impedance shunt circuit, is its behavior under normal and surge conditions. Its normal state is characterized by high impedance. This high impedance ensures that the TVSS does not interfere with the normal operation of the electrical system. It doesn't draw significant current or cause voltage drops. Only when a surge occurs does its impedance drop dramatically, allowing it to perform its protective function. The NEC allowance of high-impedance shunt circuits ahead of the main service disconnect recognizes the need to protect sensitive equipment from voltage surges without compromising the overall safety and reliability of the electrical system. By connecting a TVSS directly to the service conductors, it can intercept surges before they reach the main panel and potentially damage other equipment. It's important to note that the installation of a TVSS, even under this exception, must comply with all other applicable requirements of the NEC. This includes proper grounding, conductor sizing, and overcurrent protection for the TVSS itself. While the TVSS can be connected ahead of the main service disconnect, it still needs its own overcurrent protection device, such as a circuit breaker or fuse, to protect it from internal faults or overloads. The sizing of this overcurrent protection device should be based on the manufacturer's recommendations and the ampacity of the TVSS conductors. Grounding is also crucial for the proper operation of a TVSS. The grounding conductor provides the low impedance path for the surge current to flow to ground. A poor or inadequate grounding system can significantly reduce the effectiveness of the TVSS and may even create a safety hazard. The grounding conductor should be sized according to the NEC and connected to a suitable grounding electrode system. Furthermore, it is important to select a TVSS that is appropriately rated for the electrical system it is being installed on. TVSS devices are typically rated by their surge current capacity, which is the maximum amount of current they can safely divert during a surge event. The surge current capacity should be sufficient to handle the expected surge levels in the area. In areas with frequent lightning strikes or other sources of voltage surges, a TVSS with a higher surge current capacity may be necessary. Another important consideration is the voltage rating of the TVSS. The TVSS must be rated for the voltage of the electrical system it is being installed on. Using a TVSS with an incorrect voltage rating can damage the TVSS and may create a safety hazard. When installing a TVSS ahead of the main service disconnect, it is also important to consider the coordination of overcurrent protection devices. The overcurrent protection device for the TVSS should be sized so that it will trip before the main service disconnect trips during a fault condition. This ensures that the TVSS is properly protected and that the main service is not unnecessarily interrupted. In summary, a TVSS is considered a high-impedance shunt circuit under normal operating conditions, as its impedance is very high, allowing little current flow. During a voltage surge, its impedance drops, providing a lower impedance path to ground, diverting the surge current. This characteristic allows it to be installed ahead of the main service disconnect, in accordance with NEC section 230.94 exception no. 2, provided all other applicable requirements of the NEC are met, including proper grounding, conductor sizing, and overcurrent protection for the TVSS. Always consult with a qualified electrician to ensure that the TVSS is properly selected and installed in accordance with the NEC and manufacturer's instructions. The specific requirements for TVSS installation can vary depending on the jurisdiction and the specific application. Therefore, it is essential to stay up to date in the latest electrical codes and standards. Now, let's consider a few practical examples to further illustrate the application of NEC section 230.94 exception no. 2. Firstly, imagine a residential dwelling unit with a 200 amp service. The homeowner wants to install a TVSS to protect the sensitive electronic equipment from voltage surges. According to NEC section 230.94 exception no. 2, the TVSS can be connected directly to the service conductors ahead of the 200 amp main service disconnect. However, the TVSS must have its own overcurrent protection device, such as a 20 amp circuit breaker to protect it from internal faults. The 20 amp circuit breaker should be sized based on the manufacturer's recommendations for the TVSS. Secondly, consider a commercial building with a 400 amp service. The building owner wants to install a TVSS to protect the building's electrical equipment from voltage surges. Again, according to NEC section 230.94 exception no. 2, the TVSS can be connected directly to the service conductors ahead of the 400 amp main service disconnect. The TVSS must have its own overcurrent protection device, such as a 30 amp fuse to protect it from internal faults. The 30 amp fuse should be sized based on the manufacturer's recommendations for the TVSS. Thirdly, imagine an industrial facility with a 1200 amp service. The facility manager wants to install a TVSS to protect the facility's critical equipment from voltage surges. Once more, according to NEC section 230.94 exception no. 2, the TVSS can be connected directly to the service conductors ahead of the 1200 amp main service disconnect. The TVSS must have its own overcurrent protection device, such as a 60 amp circuit breaker to protect it from internal faults. The 60 amp circuit breaker should be sized based on the manufacturer's recommendations for the TVSS. In each of these examples, it is important to note that the TVSS must be properly grounded in accordance with the NEC. The grounding conductor should be sized according to NEC table 250.122 and connected to a suitable grounding electrode system. Additionally, the TVSS must be listed and labeled for its intended use. This ensures that the TVSS has been tested and certified to meet applicable safety standards. It is also crucial to follow the manufacturer's installation instructions carefully. A proper installation can damage the TVSS and may create a safety hazard. When selecting a TVSS, it is important to consider the voltage rating, surge current capacity, and other relevant specifications. The TVSS should be selected based on the specific requirements of the electrical system and the expected surge levels in the area. In areas with frequent lightning strikes, a TVSS with a higher surge current capacity may be necessary. Furthermore, it is important to periodically inspect and test the TVSS to ensure that it is functioning properly. Some TVSS devices have indicator lights or alarms that indicate when the TVSS has been damaged or has reached the end of its service life. If the TVSS is damaged or has reached the end of its service life, it should be replaced immediately. Ignoring a damaged or non-functioning TVSS can leave the electrical equipment unprotected from voltage surges. In addition to NEC section 230.94 exception no. 2, there are other NEC sections that are relevant to the installation of TVSS devices. These include NEC section 285, which covers surge protective devices, and NEC section 250, which covers grounding and bonding. It is important to be familiar with all applicable NEC requirements when installing a TVSS. Finally, it is worth noting that the use of TVSS devices is becoming increasingly common in both residential and commercial applications. This is due to the increasing sensitivity of electronic equipment to voltage surges and the growing awareness of the importance of surge protection. By installing a TVSS, building owners and homeowners can protect their valuable electronic equipment from damage caused by voltage surges. This can save them money in the long run by preventing costly repairs and replacement. Remember that a TVSS does not eliminate the need for proper wiring practices and overcurrent protection. It is merely one component of a comprehensive electrical safety strategy. By following the NEC and other applicable standards, and by using qualified electricians, you can ensure that your electrical system is safe and reliable. This discussion highlights the permissibility of installing a TVSS ahead of the main service disconnect under specific conditions outlined in the NEC. It emphasizes the high impedance characteristic of a TVSS during normal operation and its low impedance response to voltage surges, justifying its classification as a high impedance shunt circuit. The importance of proper grounding, overcurrent protection, and adherence to manufacturers' instructions for safe and effective TVSS installation are also stressed. Always consult with a licensed electrician for any electrical work to ensure compliance with local codes and safety regulations. The information provided is for educational purposes only and does not constitute professional electrical advice. Incorrect installation or misuse of electrical equipment can be dangerous and may result in property damage, injury, or death. If you are not qualified to perform electrical work, please consult with a licensed electrician. Electrical codes and regulations can vary depending on the jurisdiction. It is important to be familiar with the specific requirements in your area before undertaking any electrical work. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Staying up to date on the latest NEC requirements is essential for all electrical professionals. In addition to the NEC, there are other organizations that develop standards for electrical equipment and installations. These include Underwriters Laboratories, the Institute of Electrical and Electronics Engineers, and the National Electrical Manufacturers Association. By following these standards, you can ensure that your electrical system is safe and reliable. The information provided here is intended to be a general overview of the topic. It is not intended to be a substitute for professional electrical advice. Always consult with a licensed electrician for any electrical work to ensure compliance with local codes and safety regulations. This information is intended for general guidance only and should not be used as a substitute for consulting with a qualified electrical professional or referring to the latest edition of the National Electrical Code. The installation of electrical equipment can be dangerous and should only be performed by qualified individuals. Improper installation can result in fire, electric shock, or other hazards. Always follow all applicable safety precautions when working with electricity. By taking the necessary precautions and following the applicable codes and standards, you can ensure that your electrical system is safe and reliable. Remember that electricity is a powerful force that must be treated with respect. By following these guidelines, you can protect yourself, your family, and your property from the hazards of electricity.